Dear students, today we will discuss about TCP IP suite. In fact, in previous modules we have learned about protocols, and in TCP IP there are several protocols available which we will be discussing few of them in this module. So why we need such a model or such a set of protocols? In fact, manufacturers which build different devices and softwares want to communicate with other systems or softwares developed by other manufacturers, and they need a standardized method. So such a standardized model which have been formed is known as Open System Interconnection or OSI model. So this has been built by International Organization for Standardization, and it has 7 layers of hierarchy as compared to which we discussed in previous modules, the 4-level hierarchy. However, this remains slow in replacing the 4-level hierarchy because it was already in use when OSI model was proposed as a 7-layer hierarchy. So we have defined TCP IP suite, but here we want to make one distinction that this suite have many different protocols, and one of the protocol is known as TCP, which is Transmission Control Protocol, and other is known as Internet Protocol or IP. But all of these protocols, even there are many more protocols other than TCP IP in TCP IP suite, but we normally or wrongly refer all of this suite as TCP IP suite. So in this module we will be mainly focusing on TCP and IP protocols. TCP defines a version of transport layer, and there could be more than one way of implementing the TCP. Using one way could be that we use TCP, the transport layer implementation, and the other is UDP, the user datagram protocol. And why we have 2 options? In fact, this is similar that we want to ship some of the things to our friend, and we have 2 shipping companies available. So sometime, depending upon the requirements, we decide that we need to ship our things using one shipping company, which could be TCP, and another shipping company, which could be UDP. We will see further details. So in fact, the TCP establish a connection first. So whenever you implement the transport layer using TCP, it first sends a signal to the receiver, and receiver acknowledges that, okay, I am ready, now you can start sending the data, and then that data is transmitted. However, in the case of UDP, this is called a connectionless protocol because it starts sending data, and even it may happen that the receiver is not even operational, is not available, is not listening, is not receiving the data whatever is being sent by the sender. So TCP transport layer at origin and destination works together by acknowledgement, as we have discussed, and there is a possibility of retransmission as well. So for example, if the receiver tells that I haven't received this packet, then that kind of packet can be resent by the sender. So that's why this is called a reliable protocol. However, UDP is unreliable protocol. So TCP can also adjust the transmission rate depending upon the receiving capabilities of the receiver. This kind of transport layer implementation can basically enhance or reduce the speed of the transmission, and it can also avoid the congestion if there is. So until now you might be very fascinating that all of the benefits are for TCP. However, there are some benefits of UDP protocol as well. So for example, transport layer based on UDP is more streamlined than TCP because UDP is going to send the data and is not waiting for the acknowledgement. So if you are talking and you are not listening to other person, then of course you are talking more and you are transferring more data. So the requirement is that UDP can be used in such a scenario when there is someone who is ready to listen you, right? So such systems are like DNS Lookups, which we have discussed previously, and voice over IP systems. Although in email transfers where you need an acknowledgement, the TCP is a better choice. And then there is a IP, Internet Protocol, which is a standard implementation of network layer. And about this, we have already talked about network layer implementation, that there is a forwarding and routers and routing tables. However, there is another new thing which we are going to learn in this module, which is called hop count. So basically, when the packet is sent from the sender side, so there is a count of hop that is added with the packet. So hop are the temporary stops in between the communication from sender to receiver. So it say, for example, 30. So this means that this packet should be received by the receiver within the 30 hops. Otherwise, this packet will be lost or will be terminated. Otherwise, if we do not have hop count, this packet will keep rolling in the network. So normally 64 is sufficient to send a packet from one sender to the receiver, and it actually reaches to the receiver end, including all of the routers in between. So if we conclude today's module, we have learned about OSI, the TCP versions for transport layer implementation and UDP version, and then we have learned the differences between TCP and UDP and in which situations both are useful, and we have also discussed about IP.